Experiment number 2 is a preparation of alum, which is an inorganic salt. It's a double salt because it contains potassium and aluminum. In the first week, we'll be doing the synthesis of alum.
What is synthesis?
Synthesis is a process that goes from reactants to products through several reactions or just one reaction. In this lab, we'll be going through several steps to get to our final product.
In week 2, we're going to take the mass of our alum that we created in week 1 and test its chemical properties. We're going to test its melting point to determine its purity, and we're also going to test its pH by dissolving the alum in water and determining its acid or base behavior. Along with those procedures in week 2, we're going to be conducting another experiment in which we're given an unknown. The unknown contains alum and another salt. We're going to react this unknown with barium chloride, and they're going to produce the precipitate barium sulfate. Because barium sulfate is extremely insoluble in water, we're able to collect it and measure its mass. By taking the mass of the barium sulfate, we can therefore determine the mass of the alum in the unknown, which will help us determine the chemical composition.
Be sure to record the melting point, the pH, the mass of the alum, the mass of the BaSO4, which will eventually lead to the mass percent of alum, in your lab notebooks.
And be sure to read over your packets thoroughly and take the readiness test online before coming to class.
In week 1, these are the materials that you're going to be using. You're going to need the water alcohol solution. You're also going to be using some sulfuric acid and potassium hydroxide. You'll need some aluminum foil, and lastly in week 1 you're going to be weighing a crucible. Now remember, when you're handling the sulfuric acid and the potassium hydroxide, that you should be wearing rubber gloves because they are 1.5 and 3 molar. You also need to remember to wear your safety goggles and closed-toed shoes. In week 1, the materials that you're going to be using are a 50-50 water and alcohol solution. You're also going to be using 3 molar sulfuric acid, 1.5 molar potassium hydroxide. And just remember that all of these need to be recorded in your lab notebooks because these molarities are going to be very important for your data and your calculations. You're going to also be using aluminum foil, and at the end of the day you're going to be weighing out this crucible. Now remember, because you're handling 3 molar sulfuric acid and 1.5 molar potassium hydroxide, that you should be wearing rubber gloves and also wear your lab goggles and closed-toed shoes.
The first thing we need to do in this experiment is get approximately 0.5 grams of aluminum foil. When using a scale, always make sure to use a weighing paper so as not to contaminate anything. You place the weighing paper in, close all the doors to make sure that no air disrupts anything, and tear your scale, zero it out. Now, always make sure to record your numbers to 4 decimal places. And you need to make sure to not waste too much time trying to get exactly 0.5000 grams. It could be anywhere from 0.49 and then numbers after that to 0.51 something. So say you have 0.4932, that's acceptable, or 0.5127. They're all within an acceptable range. Just make sure not to be too far off. My reading is 0.5186. So I brought my lab book back with me so that I didn't have to try and remember the number on my way back to my station. Always remember to bring your lab notebook back, and always remember to record to 4 decimal places. So as you can see, I've set up my lab table so that nothing is close to the edge. Now to proceed with the experiment, I've folded up my aluminum foil, I'm dropping it into a 250 milliliter beaker, and I'm adding 25 milliliters of my 1.5 molar potassium hydroxide. Now make sure that this is completely submerged by using your glass rod. We need to heat the solution, so I've hooked a hose up to the gas. You turn on the gas. and we're going to slowly heat the solution. Make sure that it's under the hood so that the hydrogen gas can get sucked up into the vacuum.
Now, once your aluminum dissolves, you might have some black particles remaining. They're going to look like this. To get rid of these, you're going to want to filter them out. Now, you're going to take some filter paper, you're going to fold it in half, and fold it in half once again to form a cone shape. You're going to open the filter paper and place it inside your funnel. And to get the paper to stick to the funnel, you're going to take your wash bottle and just lightly wet the edges. You're going to now place the funnel inside the flask. And remember, you're filtering while the solution is still hot, so you're going to want to hold it very carefully with paper towels. Bring it over to your flask and slowly add the solution. And just wait while it filters out. After filtration, you're going to be left with a clear solution. Now you can throw away the filter paper into the trash can. However, you have to transfer your clear solution into a clean beaker. Once you do that, you're going to add the 15 milliliters of the sulfuric acid slowly to the beaker and the solution, and you're going to see white precipitate forming like this. However, if you stir, it's going to become even thicker, and eventually it's going to dissolve. Now, you should be doing this for a few minutes, and if you still have a lot of precipitate forming, you need to heat it. And you're going to need to continue to heat it until you have 25 milliliters of solution remaining. Now remember, you're going to be doing everything under the hood. So once your precipitate has completely dissolved, you're going to have a clear solution once again. And now you're going to want to take the clear solution, turn off your Bunsen burner, take the clear solution and add it to an ice bath. However, you never want to directly take your beaker from the Bunsen burner to the ice bath. You want to wait about a minute for it to cool. Once it's cool, you're going to take it, place it inside the ice bath, and make sure that you keep it as motionless as possible. Now, in these 10 minutes, you're going to see crystals slowly start to form. However, if crystals do not form, you're going to have to go back and reheat the solution one more time and place it in the ice bath again.
Now the next step in the experiment is filtration. Before we filter, once again, take your distilled water and be sure to wet the filter paper. After doing so, we're now going to take our crystals which are formed and begin to filter it. If needed, use a glass rod to get all the crystals out. Now we're just going to wait for it to filter. Now after it's done, we're going to take our 50-50 water alcohol mixture and carefully wash the crystals. But before you do so, make sure to turn the vacuum off. And using your mixture, try and wash all the crystals like so. After doing that, you turn the vacuum back on and wait for it to filter.
After you wash your crystals, you want to transfer it to paper towels to dry. Make sure you label your name and save it for next time. The last step is to weigh out your crucible and the cover, and make sure you do it to 4 decimal places and record in your lab notebook.
Alright guys, so in conclusion, throughout the point of this lab, you should have been able to determine the melting point as well as the acid-base behavior of the alum.
Okay, and guys, just make sure that you're going to keep track of all your data in your lab books neatly, because this week we're going to have 2 separate experiments, the first one being the synthesizing and the second one being analyzing. In the first week, you're going to be determining the mass of the aluminum, which is going to help you determine the percent yield of the alum. When you do this, you're going to refer to the equation on the first page of your lab packets. It's the overall balance equation. However, when you're determining the calculations from week 2, you're going to take the mass of the barium sulfate from your unknown, and you're going to use stoichiometry to determine the mass percent of the alum. When you do this part, you do not use the overall equation, you use just the mixture.
Alright guys, I'm going to emphasize once again, please make sure to read your packet, take the readiness test. Once again, if you have any questions, go see the professor, enjoy the lab. Good luck. Alright, so guys, in conclusion, throughout the point of this lab, you should have been able to determine the melting point as well as the acid-base behavior of the alum.
Okay, and guys, when you're doing your calculations, just make sure that you keep them very neatly in your lab notebooks, because this lab is split into 2 weeks and they're pretty much completely different experiments. The first week you're going to be doing the synthesizing, and the second week you're going to be analyzing. So from the first week, what you should take is the mass of the aluminum. This is going to help you get the percent yield of the alum. When you're doing this, just make sure to use the overall balance equation, which is on the first page of your packet. However, when you do the second part, from week 2, you're going to take the mass of the barium sulfate from your unknown and use stoichiometry to determine the mass percent of the alum. When you do this part, you do not use the overall balance equation, you just use the equation of the mixture.
Alright, I can't emphasize once again, guys, please make sure to read the packet before coming to class, take the readiness test. If you have any questions, see a professor. Enjoy the lab. Good luck.